Hi, this is Mrs. Putnam. I'm going to teach you how to use the partial quotient strategy. The partial quotient strategy is very similar to the standard algorithm, which is the traditional way of doing long division that most of us learned in school. There's a little bit of vocabulary that I'll be using, so I'm just going to put that on here and go over that quickly. So the dividend is the number being divided. That is the big number. The dividend is divided by the divisor. The quotient is the answer to a division problem. And then sometimes you have a remainder, which is your leftovers. Okay, in the following example, we're going to do 746 divided by 4. Now the kids might call this the big 7 because of the shape of the division box. Now we're dividing everything by 4, so I like to do a brain dump, which is just where we dump all of our knowledge of 4s, specifically the multiples of 4, on our paper so that we can refer to them. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. Don't be surprised if your kids sing that. A lot of the kids really liked when we did 4, 8, 12, and 16, 20, 24, 28, and 32. I can count by 4s. But this way they don't have to stretch their brain too much. If they write it down, we can refer to it every single time that we need it during this problem. And if we get another problem that also has a divisor of 4, we can use it again. All right, our first step is to look at the first digit in our dividend. And the first digit here is a 7. So we think to ourselves, can I divide 7 by 4? Or can I get groups of 4 out of a 7? If so, how many groups can I get? Well, 7 is greater than 4. So yes, if I have 7, I can get one group of 4. I can also use my brain dump here to show that. So 4, 8. Well, 8 is bigger than 7, so that's too many. So it looks like I can get one group of 4 out of 7. Now, this number is not actually 7. It's the 7 in the hundreds place, so it's worth 700. So we did not use the tens or ones places for this part. So we're going to use placeholders and put a 0 over here for the tens place, and we're going to use a 0 for the ones place. And that is step 1, divide. Step 2 then is to multiply. In this particular problem, we are going to multiply everything times the divisor of 4. So we're going to do 100 times 4. 100 times 4 is 400. You can use the basic facts, 1 times 4, and then you have 2 zeros. That's a skill that we learned earlier in the year, multiplying times tens, hundreds, thousands, multiples of 10. Okay, divide, multiply. Third step is subtract. So we are going to subtract. 746 minus 400. 6 minus 0 is 6. 4 minus 0 is 4. And 7 minus 4 is 3. Subtraction and subtraction with regrouping are common mistakes that happen in division. So multiplying is a skill that should be mastered at this point, and so should subtraction with regrouping. That's a very common place to find mistakes in the problems. All right, so we now have our difference. We found our difference of 346. So it is time to ask ourselves, is 346 more than 4? Can I get more groups of 4 out of 346? Well, it's a whole lot more, so I sure can. So I'm going to go back to divide again. So just like in standard algorithm, the traditional way of learning, we divide, we multiply, we subtract. Now in partial quotient, we do not bring down. So that is the one big difference in standard algorithm versus partial quotient. We also The reason I like partial quotients so well is that you don't have to be exact. You can keep subtracting, you can keep multiplying and dividing without having to be 100% correct on the first try. But don't worry, standard algorithm will be taught in 5th grade. So this is what we do in 4th grade, because we are supposed to use several different methods of division. And I think this is the one that best explains and shows what the process truly is. All right, we've decided that we can get groups of 4. We can get some more groups of 4, so we're going to look at 346. And we're going to start with that 3. Can we get any groups of 4 out of a 3? We sure can't. 3 would be up here in our brain dump, and that's not big enough. It's smaller than 3. So we're going to look at the 34 together. 34, can we get groups of 4 out of 34? Yes, 34 is greater than the divisor. And if we go over to our brain dump, we can see, okay, we're getting closer to 34, getting closer to 34, getting close. Okay, 32 is really close to 34. 36 too big, so 36 is not going to work. But the 32 will. So 32, we needed 1, 2, 3, 4, 5, 6, 7, 8 groups. 8 groups of 32. We could get 8 groups of 32 out of 34. Now again, 34 isn't really 34, it's 346. But since we're estimating, we just say the 34. Now I didn't use the ones place, so I'm going to circle that, because that's our placeholder. We didn't use the ones place, so we're going to put a ones place in our answer. And that makes more sense, because 4 times 80, we're going to do that times the 4. Remember, there's our divisor, so our divisor comes here again. 8 times 4 is 32, and the 1 0. So 80 times 4 is 320, and that is really close to 346. So far we've gotten 100 groups of 4 out of 746, and then we've gotten 80 more groups out of the 746. Next step, subtract. So we are going to subtract our 346 minus 320. 6 minus 0, 4 minus 2, 3 minus 3. You can put the 0 or not. I typically don't. Back to the beginning. Is 26 less than or greater than 4? Well, it's greater than, so we can get some more 4s out of 26. Can we get any groups of 4 out of a 2? No, we can't, because 2 is less than 4. So we'll put it all together. Can we get any 4s out of 26? 26 is greater than 4, so yes, we can. About how many? Let's go to the brain dump. 4, 8, 12, 16, 20. 24 is really close. 28 is close, but 28 is bigger. So we're going to use the 24. 24 was 1, 2, 3, 4, 5, 6 groups of 4. So 6 groups of 4. Now I didn't put a 0 here because we don't have any places that we didn't use. There isn't. We used the last of our digits, the last of our places. So no 0 here. But we are going to multiply the 6 times 4, always times the divisor, which is 24. And after we multiply, it's time to subtract again. 26 minus 24 leaves us 6 minus 4 is 2. 2 minus 2 is 0. All right, it's time to check in. Our divisor is greater than our remainder, so this remainder looks pretty good. Let's look over at our partial quotients. So first we got 100 groups of 4, then we got 80 groups of 4, and then we took out 6 groups of 4. If we put all those partial quotients together, 100 plus 80 plus 6, and I do recommend writing this down because also being able to add correctly is super helpful. And we get 186. With a remainder, don't forget the remainder, of 2. And that is how you do partial quotient long division without using a standard algorithm. Still an algorithm. An algorithm is just a list of steps and ways to do something. So it's still an algorithm. It's just not the way that I learned and probably a lot of you learned. If you have any questions or would like to see any other topics covered, you can email me at putnam_s@cneschools.org. So if there's another math topic you'd like to see explained, I'm happy to do it. But this is my first video, so hopefully it was helpful. Don't forget, you can, is it like, subscribe? But hopefully this helps. Thanks so much. Good luck with math.